This is the video lesson for translating between graphs. The learning target for this lesson is, I am learning to translate position time graphs to velocity time graphs and vice versa. The success criteria for this lesson are, I can translate a position time graph to a velocity time graph, and I can translate a velocity time graph to a position time graph. Okay, so in this first graph we have a constant velocity. So remember, the slope of a position time graph is velocity. So this is a constant slope. So we have a fairly low velocity for this part. Then we have zero velocity. So the object has stopped moving for this part. So we have zero velocity here. And then the object is speeding up as it goes back to the origin in a negative direction. So we have a little bit faster velocity here. And then we can connect these parts here. So we have a constant velocity for the first part, zero velocity for the second part, and then a little bit higher negative velocity for the second part. Okay, so for the second position time graph, we have a changing velocity. So here we have a high velocity in the negative direction, and then it starts to slow down, still in the negative direction, and then it's slowing down even further until the object gets to here, this point, and then it stops for a split second, and then it goes in a positive direction. It's going pretty fast in the positive direction, and then it slows down and goes at a faster or slower positive direction, but it's still increasing its speed in the positive direction. So, all right, so we start with an increasing negative velocity, and then it's slowing down until we come to a stop, and then we have a speeding up positive velocity, and then it starts to slow down again, but it never goes in the negative direction. It just sort of slows down. All right, so let's translate between a velocity time graph and a position time graph. So we have a constant positive velocity. So a constant positive velocity on a position time graph looks something like this. And then we have zero velocity. So on a position time graph, that just means a horizontal flat line. And then we have a slower negative velocity. So that means we have a constant velocity that's at a lower slope. So we have high positive velocity, no movement, and then a lower negative velocity. And then for the second velocity time graph here, so now we have a changing velocity, and then we have a constant velocity, and then another changing velocity. So for position time graph, we have an increasing velocity, and we have a constant velocity. So we have a slope that's a constant slope here. And then we have a curved line, but that's more shallow. So it's changing over time, but it's a shallower line. So if we look at the slopes here, we have a little bit steeper slope. So this is a steeper slope than this, which is a constant slope, and this has a shallower slope than either of these two because it's slowing down. But it's slowing down more than either of these two. But it's not going into the negative direction, so the position time graph doesn't curve off like that because it's not going in the negative direction. All right, everybody, keep asking questions. It's how you learn new things.